Hi, everybody. So today we will talk about product quality, and we will more particularly focus on automated testing. So I'm Pierre Gall. I'm head of product development at the Embedded Kit. We are delivering solutions for around embedded Linux, from distribution to the toolings needed for achieving this level, expected level of quality for our customer. We will start with how maybe just to focus about why we need to do testing and why we need now more and more automated testing. In fact, product becomes more and more complex. I'm pretty sure that everybody's aware about that. Even in microcontroller development, we see that the feature integrated into this new embedded product are more and more complex. We are talking about complex algorithm. We are talking about security, as we have seen before. We are talking about connectivity. So having automated testing strategy become more and more key to being able to maintain the product quality inside the development of a solution for equipment manufacturer. Let's take a few minutes talking about what we call the pyramid of test. That's more or less what we have, how we can describe the level of testing we can provide. We will start with the really low level testing, what we call unit testing. So it's not really part of the pyramid of test. In fact, it should not be there, but I really would like to differentiate the different level of testing we have when we are in a testing environment. Unit testing is really dedicated for algorithm or dedicated function. I'm pretty sure that everybody is aware about different frameworks that allow to perform this type of testing, a small part of the code that you've developed. What is becoming more and more interesting is about component and integration testing. Component testing really means I would like to focus on a specific features of my system. When we are talking about embedded system, we could talk, for example, about a specific driver or a specific service. And integration testing is more about having multiple components working together to achieve a new features. The best example for that is the OTA update. When you would like to perform an OTA update in your embedded system, you need to integrate testing of the boot, applying the flash driver, the bootloader, the transfer of the update solution. So it's really integration at an integration level. And at the end, you find what we call system test, which is more or less how the user will use the product to perform something. The end goal of the product, the business usage of the system. What is interesting here is to understand the type of test we can apply. And for sure, for component testing and integration testing, automated testing really makes sense because it gives you the opportunity to make new type of tests, and we will see that during our today presentation. But we cannot say that automated testing is the miracle solution for all the testing purpose. For sure, when we start having system testing, like we like to integrate application plus some pure business features, pure business usage, automated testing could become really, really expensive to implement because you have to maintain a lot of very specific use cases. So today we will really focus on automated testing, will help you to achieve better quality, and focus on component testing and integration testing. I will give you more detail about the type of test and what I'm talking more in detail about this component and integration testing. Last information interesting to share. The bottom in this pyramid, you can discover a bug very, very earlier. If you discover a bug during the system testing, it's the time between the bug, the time you write the code and the bug you discover could be really, really long. And fix a bug that you have on a code that you have just written a few days ago is something easy to fix. Fix a bug in a complex, good global system that you have developed a few months ago could become more and more complex, so more and more expensive for the development team. I continue. After this pyramid of tests, we will talk a little bit more about why using automated testing, because you can definitely use manual testing with some QA and tester that is well organized to perform and to review the quality of the development, but automated testing can bring some addition of what the test and the QA team can bring. One first added value is having a determinist and reliable test procedure. With automated testing, you have something that you can run it again, maybe every day, every week, every month, and ensure that you will exactly perform exactly the same time, the same procedure. So you will validate something which is more deterministic. The second added value is about having a real continuous testing environment. So it will help you to ensure the day-to-day quality of your product. Make sure that if as soon as you commit a new feature, merge a new pull request, you can run this set of tests and discover if it has been an impact on the development of the product. And it will also open a new type of testing. And here, the perfect example is about long-term robustness. It's definitely not human doable to try to reboot your system thousands of times, but it's very, very easy to implement in an automated way. So being able to open new type of testing with the automated testing is something key to ensure robustness and reliability of the system, or detect the low occurrence bugs that could occur for some specific use cases. So as you can see, automated testing bring additional value on top of what a QA team can already done. And I think the type of test could be really different, and both of them can allow to achieve this high quality product all OEM or device maker wants. Is at the end, the non-regression testing is maybe the most interesting fact with the automated testing. You will be able to run this test on the day-to-day directly into your continuous integration or with your pipeline, and being able to do that on a daily basis will help to achieve better product quality. Let's continue and now focus a little bit more about embedded Linux system, because today we would like to share a little bit more about how we can achieve automated testing to enhance the quality of Linux porting on a specific hardware. What need to be tested? We will not talk today about business application and connectivity. We will more focus about operating system, services, and also about kernel and drivers, because when you start implementing your own Yocto Linux-based Linux solution on your specific hardware, you will probably grab a BSP coming from the silicon vendor or your sub maker and starting building a complex environment with external source, with your own development. And validating that your operating system is running well will allow you to go further in terms of quality of your product. The first solution I would like to talk about today is about the p-test. We are all here to talk about Yocto, and Yocto provide and Open Embedded provide a solution named p-test, package test, that will allow you to perform the integration of a specific type of tests. It's more self-testing solution. So the p-test will run directly on your board, and the p-test will allow you to build. So that means package your solution of test, install the test you want, run it, and also deliver a standard report with something which is ready to be parsed by an external tools, for example. With the p-test, we are mainly talking about component testing. You can run it very easily. You have specific command line. I will not go in the detail on how to deploy, build a p-test. You have good documentation for doing that, and pretty sure that everybody can do that by the documentation review. And you have a long list of packages that already integrate some p-tests. So as soon as you will integrate in your final Linux image some of these specific packages, you can easily run this suite of tests to validate that everything is working properly inside your final test environment. If you want to have a look on the detail of all the available p-tests, there is a dedicated page in the package page of the Open Embedded website to review that more in detail. So p-test is a good tool. It will allow you to validate a certain amount of system validation. Let's continue with another project that allow you to perform tests, the LTP, so Linux Test Project. That's a huge repository of tests. So like the p-test, it will allow you to validate the global reliability, robustness, and stability of your Linux system. You have a large set of tests, where p-test is more focusing on some application package. The LTP test is really focusing on the Linux system kernel. So you have here is just some example of test cases you will be covered by the LTP. Running it is like the p-test, something quite simple. You can specify the test you want to run. Very interesting to run on a specific platform, very, very long, complex, and you will have a lot of results to analyze. So if you really want to run all the tests from the LTP suite, it will take time to run and also take time to analyze. But it will give you a really good picture of the global state of your system. And for sure, you will have to accept that some of the test does not pass for some reason that is acceptable. So you can't expect 100% validation with the LTP, but will give you a good idea of the current status of your system. Really useful in this Yocto and embedded system context to validate the integration on a specific hardware. Here we are not in the x86 server area. I'm really focusing on embedded world, and in this embedded world, we are always using a specific BSP coming from the silicon vendor, maybe modified by the sub maker, maybe modified by the device maker. So that could have impact on the global stability and reliability of the Linux. And this tool is an excellent one to be able to run a global sanity check of the system. Once again, we are here talking about really component-specific features of your system. We can continue to talk about additional type of tests that are not covered by standard test suite. How can validate my serial port is working well, my display, my Ethernet controller, my Wi-Fi driver. Wi-Fi driver is the one we will use as an example at the end of this presentation. So we will focus more about how we can validate a Wi-Fi driver in this automated way. I would like here just to take an example to give you the level of testing we can imagine. For example, the RTC, so we have real-time clock, the management of the time in the system. We can imagine to integrate different level of tests that could be all automatized, and where automatization really fit well. So read the time, set the time, compute the drift of a specific RTC. Some system does not have a NTP sync, and we can imagine that we would like to check if there is a drift, and that could be really well done in an automated way. I set a specific time, I wait for a specific amount of time, I check the current time, validate if there is a drift. So all of these tests could be really interesting to automatize because cost more or less nothing to do and to create, but could bring you a good idea of sorry, of the global system. Some of these tests could be covered by the LTP. For example, the RTC is already covered by the LTP test, but not all of them. Read and set time is covered. A part of alarm is covered, but drift validation is not covered. So once again, if you have a specific requirement and you want to be really careful on a specific feature, already dig into the detail of what the already existing test suite can provide to be sure that it will cover all of your use cases. Here we would like to move a little bit, just a few words about integration testing, because that's really become very, very interesting to automatize when we start talking about integration testing. As you can see, there is multiple type of ID. I just threw in this slide to show you that we can perform integration testing on a lot of different features. You can see that there is already also Wi-Fi here, and that's not an error. In fact, you can have Wi-Fi testing at a component level and also Wi-Fi testing at an integration level. I will show you that more in detail after that. So system startup is something which make a lot of use of different components. It uses bootloader, the kernel startup, the driver initialization, the log system, the first file system. If you are in a In a secure boot, you have all the Verity integration check and so on and so on. So you can perform a lot of interesting integration testing. Would like to give you an example with the OTA update. What kind of test you can automatize when we are talking about OTA update. Validated the good and the bad signatures of a file, of your update file. Validated what happens if a power failure happens. Validating if the version check is correctly done. Perform update endurance by performing thousands of updates in a row. There is a lot of stuff that you will be able to perform with a automating environment that could make sure that what you delivered in the market is at the expected level of robustness and quality. What you see here, if we take the example of power failure, for example, is that it will need a little bit more than just running an application on your target. So we have to talk a little bit more about the environment of automated testing. And what is here is just an example of a common way to perform automated testing. So on the left, you have your host, like we call that a test orchestrator, that will interact with your device, the device under test, and validate how the system behave in different conditions. The most important in this automated testing environment is to be sure that you are in a versatile environment and be ready to integrate additional tests without having to build something complex over what you have already set up. So what we usually do is basically to be sure that we can interact with the target using a console. Could be a SSH console, could be a serial console, whatever. Most important is to say, okay, you have a huge set of action to execute on your device to validate if everything runs correctly. So having a console interaction with the system will be the basics to being able to run the test. What is interesting here is that you will be able to run, for example, the LTP test or the P test directly from your host, getting the result, pass the result in your host test orchestrator, and then validate what's happened during the test environment. So a host, a device under test, and being able to interact with your device. What could become very interesting is to add an extra way to interact with your device. For example, you have Bluetooth. Imagine your test orchestrator is a PC, laptop running a Linux with Bluetooth support. You can interact with your device through Bluetooth line. So you will be able to perform some type of test, very interesting, because you act as a user, but in an automated way with a machine. You can imagine to use a G-tag to program your device, to access the memory, a serial port, a CAN bus, USB to CAN, a power supply to switch on and switch off your board. So create this versatile test environment is a key success factor for the deployment of an automated testing strategy for product development. Let's focus on our example now, because I said a lot of stuff, but I really would like to give you detail on how we can implement such type of automated testing. Validating a Wi-Fi driver is not something easy because there is a large test spectrum. First, you can imagine component testing. So driver initialization, communication with the Wi-Fi chipset, could be SDIO, could be PCI Express, could be you have some low power mode. So there is a first level of testing, which is how my driver behave itself in the system and how I can interact with my Wi-Fi chip. We have also what we call integration testing before, how this system interact with the other part of the system. So scanning a folder, scanning the available access point. It will require, I don't know, maybe WPA2 supplicant. It will need a router. It will be part of a global environment. And you have the major tests we describe here are what we are doing for our customers. So scanning access point, connection and authentication, latency measurement, reconnection robustness, performance measurement. One key topic on performance measurement. Till now, we speak a lot about a test that could be success or fail. What become interesting with automated testing is that you can also add a new type of test, which is performance measurement or KPI. I would like to achieve a boot in less than 10 seconds. I would like to achieve 500 megabytes per second on my Wi-Fi link. So you are also able to define some criteria of success that could be some measurement, and measurement is something that you can easily implement in an automated way. So you have a lot of tests to perform, and what becomes really interesting is that it's occurring with a huge number of parameters. In Wi-Fi, you have two main bandwidths. You have a huge number of sub-channel. You have the channel width. You have the standard of communication, the authentication mode, the protocol on top of it. So there is a lot of parameters that have to be validated to ensure a good behaving of your system when it will be on the field connected to a specific customer routers or a specific Wi-Fi industrial Wi-Fi. So really important to be enabled to validate all the different modes and also all the cross version of the mode. So you should imagine to check all the frequency in all the authentication mode, you start to have a huge number of possibilities. And that's where it becomes mandatory to create a real automated testing strategy. Let's see how we can do that. So we are in the same schema than before. We have our test orchestrator that will run and orchestrate the test. We have the test, the device under test. Could be, I don't know, maybe a coffee machine, a smart coffee machine. And we would like to be able to control it. So first, we will use a power device unit, something that will allow you to control power on, power off of your system. That will allow you to first reset up the environment of test just between each test. It could also be interesting to perform some power off during some Wi-Fi connection, just to validate how the system behaves and if it reconnects correctly the time after. So being able to control the power of your equipment is a key and a basic topic when you start automated testing. Then we will need a console interface. We will use serial connection because we will use the Wi-Fi and the Ethernet connection for the testing purpose. So we open a serial connection and we are able to launch command like controlling Wi-Fi with a WPA supplicant, for example, and ask the system to connect to a specific equipment. And then we will need a Wi-Fi router that we can configure automatically. Here is an example of a router we can configure through a small HTTP API. There is a lot of different models of router. We already find some of it that could be configured automatically with an API. So the test orchestrator you see on the left will be able to configure the Wi-Fi router in the appropriate mode. Then through the serial connection, you will ask the device to connect and ensure that everything is running well. So just first step, correctly define your test automation environment. And then let's focus on the different use cases. So we have our orchestrators that will configure the router. So through the Ethernet stable connection, through some API HTTP call. The router is in the good mode. We can ask the device to run a specific command to connect to the dedicated access point that have been created into the router. We can here already analyze the output of the WPA click command. We can wait for a specific amount of time, wait for the connection. The device will connect, or at least should connect, to the router. And then you will be able to ping your device and maybe analyze the latency of your system. So here you see basic use cases, but I let you imagine that you can create lot of different Wi-Fi access points, one in 2 GHz, 5 GHz, web, WPA, WPA2. You can see here that through just basic configuration, you can already have an environment that will validate that your Wi-Fi driver is ready to be connected to a huge number of different parameters of Wi-Fi. I take just few seconds to talk about how you can orchestrate that. You have a lot of different tools to create that. At the embedded kit, we are creating one that is named Pluma. And here is an example of how you can integrate this access point to connect to the system. But it exists a lot of different solutions to integrate automated testing. There is Lava, there is also LabGrid, there is a robot framework that could be used to create this kind of scenario. Each tool have added value and pro and cons. We have designed our tools to allow this high-level interface. So as an example, you can see that we would like to integrate the access point connect test, and you can specify and overload some parameters to check some specific frequency, specific standard for the dedicated channel width. And you can imagine to create high-level testing solution that will help you to just through a basic configuration generate a huge number of tests automatically. I continue with another example, which will be performance measurement, because that's also often a key topic for our customer. So we imagine that our system is already connected, and the orchestrator, through the serial console, can easily start an iPerf server on the device, and then run a local command, the iPerf client that will connect to the equipment and perform the testing. At the end, the orchestrator will parse the result of the iPerf command, which is quite easy to parse with a few lines of Python script, and you will be able to get a good idea of the performance of your current solution. As you are in an Ethernet connectivity between orchestrator and routers, you know that you are more or less testing the Wi-Fi bandwidth of your equipment. The same than before, just an example of how we enable that in our tools. We have a iPerf high-level test description that we can easily override with some parameters. And at the end, you see this metrics, which is a way to export the metrics from this iPerf testing. I think that will be time for a conclusion now. So just a key takeaway for today. What is important for me to remember is start talking about testing strategy. Talking about tech is good and important, but first, it's always really important. And I see too much of my customer not taking time to just make a step back and looking what they would like to achieve. So having this idea of building a test strategy by integrating what type of testing approach I want to do and what I can and what I need. Unit test, component testing, non-regression is really important. Ensure also to well define the roles between who is in charge of what, and there is always a gap between what the developer thinks the QA team do and what the QA team thinks that the developer are doing. So important to well define the line between the role of everybody in this testing strategy. And when we are talking about automated testing, developers are always an important role in this strategy. Be aware about the environment. Do you need a simulator? Are you able to run an environment? What kind of host can you use? Are you able to build a cheap test environment, or does it cost a lot because you need some extended hardware? How you can integrate that into a continuous integration environment? A lot of questions to think, and everything I've answered and could be integrated in a system. Reporting, how you want to perform your final report. Do you have a dedicated tools for that? Do you have only basic, what you will do with this result of test? And at the end, you will think about tooling. Do I have tools to help me to go faster in my automated testing strategy? Do I need some simulator that develop dedicated system? That's a good question, but yeah, to finish, really think about, technically speaking, a lot of things are achievable. The main issue is about how you want to deploy and be sure that you will have a real long-term usage of what you are started building with your automated testing solution.